In lesson 7 through 9, we're going to be talking about the kind of patterns that you can find in scatter plots. So remember that scatter plots are graphs like this, where you have a bunch of points kind of scattered all over the place. So there are two kind of things that you can always see in a scatter plot. You can see clusters, which are groupings of points, and you can see outliers, which are ones that don't really go with the pattern. So let's start by getting down some formal definitions. Our next one, outliers, is exactly like it sounds. They're outside the normal. So you'll have some sort of trend, and then this one really doesn't fit in with the others. It's way out in the middle of nowhere. So now let's take a look at some examples and see if we can identify these two things in those scatter plots. So let's start by identifying some outliers. I always think that's the easiest one to see which one just doesn't really match. So looking at this graph, we have study time as it increases, and then your mark, your percentage, essentially what your grade is. So we have definitely this positive trend, which makes sense that the more you study, the higher your grade's going to be. But we all know there's kind of going to be exceptions to that rule. And in fact, there's kind of one super obvious one that doesn't match the trend. This guy right here is definitely an outlier because he doesn't really match the trend. So he's going to be an outlier. Let's take a look at another graph. So here we have another graph. We have a general linear-ish trend. It's not super contained together, and that's okay. It doesn't need to be super close together to still be linear. We have this kind of general positive trend going on. So which ones are outliers? Well, there's a couple that are really obvious. So I'd say definitely this one. But here's the thing about outliers. It's kind of up to you to decide what's part of the normal trend. So, and you see this a lot in statistics where they can kind of disregard any data point they want by just calling it an outlier. So there's a couple other on here that maybe you want to define as an outlier, and that's totally okay. So why don't you go ahead and circle the other ones that you think are outliers, and then we'll talk about it in class. So now let's take a look at identifying clusters. Sometimes clusters are super obvious, and sometimes they might just be a couple points together. So here we have the eruption time versus the time between eruptions for Old Faithful. And you kind of see that there's almost two trends going on. We still have a linear and positive trend going on, but there's data within the data, essentially. We have two clusters here. You kind of have one down here, and we have one up here. So those clusters kind of tell us something. They tell us that if it's a shorter eruption time, then there won't be that much time between eruptions. Whereas also, in addition, if we have a long eruption time, then we're going to have a long time between eruptions. And it seems like Old Faithful likes to do only one or the other, not so much too much in the between. Let's take a look at another graph. So here we have another one. We don't really know what we're talking about. We just have something going up and another essentially going down as the other one, because this is a still linear, but it's a negative trend. So where are the clusters there? I'm actually going to let you decide where are the clusters in this graph. So go ahead and draw yourself where the clusters are in this graph. So we can always tell a lot from when we have something that's linear, especially if we have a line. When we have a line, we can tell our slope, so essentially our rate, and we can tell the starting point, our y-intercept. But with scatter plots, it's too vague for us to really tell exactly what the starting point is and what the slope is. What we can do is we can kind of generalize a line within the scatter plot so that we can identify the slope and the y-intercept. So taking a look at this scatter plot right here, we can tell that it's pretty linear and it's negative. So I just want to kind of fit a line to this trend. So I'm just going to take a ruler or anything you have around that has a straight edge, and we're just going to draw a line that kind of goes through the middle, or essentially the most of the points of this scatter plot. So taking my ruler, I'm just going to kind of put this right in the middle of all that, and I'm going to draw a line. So this is what it means when it says fit a line to the trend. We just fit a line that kind of goes through about what the scatter plot is telling us. Because we know the scatter plot is a collection of data, and we're kind of summing it up in a line. It's okay if ours are a little bit different, but all of ours should look about pretty much the same right in the middle there. So let's take a look at this other graph. We have ice cream sales, so as the temperature increases, so do the sales, which makes sense. If it's a hot day, you're going to want ice cream. So I want you to finish this one up. I want you to draw a line that fits this trend. Draw a line that goes through pretty much the majority of these points, kind of summing up what this data is telling us. So go ahead and draw your line there. So we can tell a lot from a line. We can tell the starting point and we can tell the slope. And when we draw a line in the middle of our scatter plot, well, then we can see those things too. We can essentially see how much is going up and over and what our starting point is. But if we want to take an equation from that line, sometimes that's not so easy because we might be going through points that aren't whole numbers. So something to keep in mind when drawing your line is you want to remember to draw one that's going to give you nice numbers. So let's put that in right here. This is not to say to not draw an accurate line, but if you can fudge it a little bit so that you're more on like a half opposed to like 0.352, it might make things a little bit easier down the line. So now we're going to take the same thing that we were just doing, we're going to draw a line through our scatter plots, but in addition, we're going to find the equation of that line. So let's take a look at this one right here. So we have to draw the line that fits the trend and then determine the equation of that line. So here we have some sort of scatter plot, and there's definitely a linear trend going on. In fact, it's almost a straight line. Oh, but some of you are saying, wait, what about that point way up here? Remember what that's called? This is called an outlier. And the nice thing about outliers is we can kind of pretend they're not there. So as we draw our line, we can just pretend he's not even there. Because if we did draw our line and take him into account, it would take us somewhere in the middle here, but we don't need to be there. We can just say he was an outlier, something was wrong with whatever data we gathered from him, he doesn't count. We're just going to talk about these guys that do fit the trend. So we're going to draw a line that goes through these guys. And remember, as you're lining up your ruler or whatever you're using to draw your line, that you want to kind of stick to whole numbers. So I'm thinking that this line, if I put it right here, so I'm lining up to 120 over here, and then maybe I want mine to line up with this point on the outside, which is about at 16 and 150, and I can just draw my line. So you can see it pretty much makes it kind of close to what it is, but then we now have nice numbers that we can work with to make our equation. So our base equation, of course, is always our y equals mx plus b. That's always where we're starting with. So now we just need to figure out our slope, throw it in for m, and then our y-intercept and throw it in for b. Well, we definitely know our y-intercept because that's our 120 that we started at. So now we just need to figure out essentially what our slope is. Well, we know two sets of data. We know that we started at 0 and 120, and then from 0, we went over 16, and we went up, well, from 120 to 150, we went up 30. So remember, it's rise over run, so it's going to be 30 over 16. And you can leave it like that, or we know we can reduce it to be 15 over 8 x plus 120. Now you might be thinking, oh, that's not really a nice number, but you know what, it's close enough considering the fact that of what number we could come up with. 15 over 8 is not that bad, and it still tells us something. It tells us that the pattern is essentially up 15 over 8 every single time for our data here. So now let's take a look at this one over here. So once again, we have our scatter plot. It's linear and it is positive. So let's draw a line going through this. So lining up my ruler to kind of go through the middle, you might want to think about how to fudge it a little bit so that it's going to be going through a nice area. You might notice that 0 is right here. So our y-intercept might actually be negative, and that's okay, as long as that's what we want. So maybe we want to fudge it a little bit so that our y-intercept is going to be -5. That's not such a bad number. And then you can determine essentially where you want your line to kind of line up with. So I'm going to let you finish this one up. So draw a line that kind of gives you nice whole-ish numbers. And it's okay if your line doesn't quite match everyone else's, and then our equations might also not quite match up, but they're going to be kind of close. Okay? And remember, any of them that you don't like, you can kind of decide are outliers. So like this guy up here, which doesn't match anything, we can call this guy an outlier. And then we can kind of ignore him. So go ahead and finish this one up. So draw your line and then write your equation. And that's it for this lesson.